Today I am going to calculate one numerical method in chemical engineering problem. So that problem is here. Consider a mixture of 25% ammonia and the rest nitrogen and hydrogen in a 1:3 ratio. The gas is at 270 atm and 550 Kelvin. Use Excel to compute the specific volume using Redlich norm equation of state by bisection method. Now I am going to solve this problem. Solution. So here first assume amount of gas mixture is 1 mole. Now how much ammonia is there? Ammonia is 25% ammonia, so 25% ammonia. So that means amount of ammonia is 0.25 mole, and rest amount is hydrogen and nitrogen. So amount of hydrogen and ratio of nitrogen and hydrogen is 1:3. So amount of hydrogen is equal to 0.75, that is rest amount, into 1/3 is the ratio, so ratio will be 1 by hydrogen is 3 by 4, and amount of nitrogen is 1:3, so that will be 0.75 into 1 by 4. So means how much? 0.75 into 3 by 4, that is equal to 0.5625, and amount of nitrogen will be, that is 1:3. okay, so 1, then it will be 0.1875. okay, we know. So total amount will be so total is actually, if you add that, so that will be 1.00. Now here what is given? So now P is given, so P is equal P in atm, that is given atm, so that is P is atm, that is given, so that is 270. okay, and then T is also given, so T is also given, so T is here, T is in Kelvin, so that is given Kelvin, that is 550. Now based on the data we can also take R value, or maybe we can take liter atmosphere, so that will be liter atm, then mole Kelvin, so that we can assume 0.0825205, and then we can also calculate volume, that from ideal gas law we can calculate the volume from the ideal gas law. So formula is here, so PV is equal to N at T, N is equal to 1, so V is equal to RT by P. So from here we can calculate V from ideal gas law, so that will be R into T by P. So that is 0. So that is in liter per mole. Liter per mole. So that we got from the ideal gas law. What will be the volume? Now here, so first we have to write component wise. So component. So NH3 ammonia. I can write ammonia. Okay, that is very big. Again, small ammonia. Then nitrogen. And then hydrogen. So amount is ammonia is 0.25. okay, and then nitrogen is 0.1875, and hydrogen is 0.5625. okay, so that is given. Okay, you can make small also, 14. okay, now this is the ammonia. So total will be this plus this. I can do that, sum of this. So that must be 1. okay, now from here we can also calculate mole fraction. Mole fraction means individual mole by total mole. So that is total mole. okay, so individual mole by total mole, so that is mole fraction. So we know that mole fraction is equal to individual mole by total mole. So from here we can calculate. So total mole is 1, individual mole is like ammonia 25 divided by 1. So that will be like that. And then if we do that, even we can also do like this divided by this. okay, then equal to this divided by this. So we can do that. So this mole fraction is given. Now we have to calculate specific volume by using Redlich equation. So what is the Redlich equation formula? So we know the formula is here. So that is the Redlich equation formula. You can put it here. So this is the Redlich equation formula. P is equal to RT V minus B, or we can take this one is the Redlich equation formula. So P is equal to RT V minus B minus A V into V plus B. So that is, an A is 0.42748 R square TC square PC by alpha. B is equal to 0.08664 RPC PC, and alpha is equal to 1 TR 0.5. So TR is actually reduced temperature, TC and PC is the critical temperature and pressure. Now this is the equation. Now from here, first we have to calculate, we need the data, the TC and PC. So then we can go one by one. So first we have to get the data. So TC, that is critical temperature. So that we need, and PC, we also need PC. PC is critical pressure. So that data we need. So ammonia, that is that critical temperature, you can search in internet. So that we will get 405.56, and nitrogen critical temperature is 41.145, and it is nitrogen. Oh, sorry, nitrogen is, I think, okay, I have data. Okay, so nitrogen, ammonia, hydrogen, nitrogen. Okay, nitrogen. Okay, critical pressure and temperature is this. Nitrogen or nitrogen. So nitrogen is this. Sorry, this. Hydrogen data is there. Hydrogen is this. Hydrogen is this, and for ammonia the data is this. You can take that data, so you can search internet, you will get that. So here temperature, critical temperature for ammonia is 405.56, pressure, critical pressure is 11.3, nitrogen critical temperature is 126.192, critical pressure is 33.5, critical temperature for hydrogen 41.145, and critical pressure is 20.8. Okay, so we can make box also. That is here. Okay, now first we have to calculate TR alpha. So first calculate TR, reduced temperature. Reduced temperature. Reduced temperature we have to calculate first. Okay. Reduced temperature TR. TR is nothing but T by Tc. So now here T is already there. T is here by Tc. Tc is here. Now here T will not change, so we make the dollar sign. Okay, then it will be like that. Then if we just drag that, so we'll get, so here you can see that is critical temperature by, for individual component, so we got TR, reduced temperature. Next we have to calculate alpha. So alpha is here, that is given 1 by TR to the power 5. So that is equal to 1 divided by TR to the power 0.5. So we'll get that alpha also. Okay, then we can calculate AI, individual component A and B we have to calculate. So AI you can calculate, AI we have to calculate. So AI is nothing but, sorry, okay, so that is alpha. Okay, AI. Now we can calculate individual component AI. AI is equal to, you can see here, 0.42748 into multiply r square. R square is here, r square, so that is not going to change, so we make the dollar sign. Okay, that is also square. Okay, and then into TCI square. TCI is here, that is square, divided by PC. PC is here, and then this whole thing into alpha I. Alpha is here, alpha I here, alpha is here, alpha I. If you do that, we'll get 3.65202.926. Already I calculated one. Okay, fine, that is correct. Now if we drag that, we'll get AI. Now we have to calculate BI. So BI we have to calculate. So BI will be, so here is equal to 0.08664 into R. So that R value will not change when we drag that. So that's why I put dollar sign into TCI. TCI is here by PCI. PCI is here. So if we do that, we'll get that. Finally, we'll get that. Now we have to calculate A is equal to summation of yi ai 0.5 square. So first we are going to calculate yi and ai, yi into ai to the power 0.5. First we are going to calculate that. So that will be is equal to yi is here. So okay, so you can write that. So that is yi. Okay. So yi is equal to yi into ai already got that, to the power 0.5. If we calculate that, we will get that. Now if we drag that, we will get yi to the power this. Now we have to take the summation. Summation will be like that. Okay. Summation. Cancel. Okay. Summation, if we drag that, we will get the summation. Okay, so we don't need that. The summation. Okay, so that is the summation, and then yi. Okay, so first yi into bi we have to calculate. So then we have to calculate yi into bi. Similarly, that is equal to yi into bi. Bi is here, so that we will calculate, and then we will get that, and then we have to add that. So now we are getting that yi, summation of yi ai is to the power 5 and yi. Now a will be a and b. So now b will be simply summation of that. So I'll just merge this column. Okay, so that will be nothing but this value is equal to this. Okay, so that will be like that. Okay, and a will be merge, and then that will be equal to this value into square, whole square into square. If we do that, that will be a and b. So home and this value, and we can make bold also. That is our a and b. You can take a and b. A and b, already we got a and b. So you can bigger. Okay. So now we got a and b. Now we can use bisection method. So we know all this. Now we are just here. I can put here. Now we are going to the bisection method. So we know the bisection method. So here bisection method is here. So bisection method is a numerical root finding algorithm that works by repeatedly dividing an interval in a half, and Redlich norm equation already know. So now here if we reorganize, so that will be fb is equal to p minus rt v minus b. So now here that fb is equal to 0, mean p minus rt by p minus b plus a p into p plus b is equal to 0, and we have to take the interval vl and vu, where fb will be the vl and fvu is the opposite side, so root lies between that, and compute first vm. Okay, so we'll go one by one. So first we have to take that v lower value low, and v high value and then we have to take v mid value, So now here ideal, from the ideal gas law we got this. So now low value, suppose I'm choosing very low value, suppose 0.1, and high value I'm choosing maybe 0.3, so I'm choosing that. So midpoint will be what? Midpoint will be, so average, you can take that avg, average of this and this to this, so that will be average will be 0.2. Now here first we have to calculate middle. So first we have to calculate f of v low, v low and f of v high, okay, and then f of v mid. So you have to calculate that mid. Now here what is the fv value? Fv value is here, okay, so we can write here. So fv value, f of v is equal to p minus rt by v minus b plus a by v into v minus b. So that is my fv value. You can see here also p minus rt v by v minus b plus a v into v plus b. So that is my fv. Now from using that v value, so v function of v is equal to this, so we can calculate fv low. So that first we have to calculate. So for that p, so p is here p, okay, so that is not going to change, okay, so that is constant. P minus r value will not change, at r, okay, dollar, okay, p r into t is here, t is also not changed, okay, so this and this, okay, rt divided by v minus b. So v is here minus b will change, b will not change, b is already I got, so this value will not change, so this is the constant value. Now plus a will also not change, so I'm marking as a dollar sign, okay, by v will change, so v is here into again v minus b will not change, so b is here, so that is okay. So after doing that, so we'll get, so v low is this, okay, v low is this, okay, then we have to calculate, similarly we have to calculate fv high also. So we can take the formula here and copy it and change the cell, so this is okay. So now, so this is equal to, maybe we can paste that, so here to, now here you can see, so that we have to change, so 29 to e here, that is okay. So g is here, so g, that is changed to h, that is changed to h, and that is changed to h. Then our formula is okay. Then we can calculate this. Then we can also calculate, okay, so that h, so just change the formula, so use this v mid. So now here g will change to h I, here is also I, rest of the things will be same, so I, and this is also I. Now if you do that, so we can calculate this, means what I'm going to do is that, so we are putting that v value here and we are getting the total value. Now you can see here, now this is negative and this is positive, so positive, negative, so obviously we have to do the bisection method. So first we are doing that bisection, is this plus this by 2, so that is this, and we are going to calculate that what is the f value. Now here you can see, so this is negative, this is positive, this is positive, so our root lies between f low and f mid, okay. So now when it will be like that, so when that root lies between, if Vm and Vl is the opposite sign, so update the interval Vl and Vm, otherwise this. So now you can see that VL and V opposite sign, so V will change, so that will be 0.2, and that is as it is 0.1, and then we have to calculate the midpoint. Okay, so and then again we have to calculate FV, then F high. Okay, and then what will be the M mid, what will be the value of FV, so that will be this. Now you can see, so this is positive, negative, this is positive. Okay, so this L and M is positive sign, so that is not opposite. So root lies between F high and M mid, so means F high 0.2 to 0.5. So then the F low will change, so that will be 0.15, and 0.2 will be as it is, and then we have to calculate mid value. Okay, again we have to calculate all this, then again we have to calculate, and then again we have to calculate this at FVM, what will be the value of this FV. Now you can see, now FL is negative and FV high is positive, FVM this. Now root lies between F low and VM. F low is already there, 0.15, and F mid is, that will be changed to F high, 0.175. Okay, now we can do this as it should looking good. Okay, now here, so now again we have to do that. Okay, now we have to calculate again F of VL and F of V high, F of VM midpoint. So you can see that now here F low is negative and F VM is positive, so now FL become F high, so that will be 0.1625, and FVM, so F high will be there, F high is 0.175. Okay, now we can do the calculation, already did that. Okay, so that is okay, that is okay, that is okay. Now here you can see this one the negative and this one negative, so now root lies between VI and VM, so VI will be low. Okay, so now VM will be V low, so that will be 0.168875, and the V high will be as it is, 0.175 as it is. Now it will be like that. Okay, now this is very low, and this is negative, this is positive, this is negative. Now root between the V high and VM, so VM become VL, so that is 0.171875, and VL will be as it is, 0.175. okay, and then you can see that, so 0.1734375. again same thing happened, so again that VM become VL, 0.1734375. V high will be as it is. Okay, now that will be same. Okay, now that is 0.175, so you can see that. Okay, now this value is becoming narrowing and narrowing. Now this is negative and this is positive, and this is okay, this and this are positive, negative. So now VM become V high, so that will be 0.17421875, and V high will be as it is, 0.1734375. okay, now you can see that is coming very small. Now if you do that, so our that original value V gas is this. Now if we do couple of, now here VM is negative, so this is positive, so that VM will be below. Okay, so that is 0.17382625, and V high will be as it is, 0.17421875. if we do that, now it will be like that. So 174, it should, that root should be lies between this. Okay, 40. 40. Now this is positive, this is negative. Now V high will be this 0.1740225, and that will be as it is 0.1732265. Now if you do like that, it will be narrow and narrow, and it will become, so you can see that. Okay, so this is, again we can do that, so that will be, okay, so high, and sorry, we can put as this value, and this value will be like same, and we have to do that, and then we have to calculate high, okay, midpoint. Okay, now here that is 0.003, very less value, so we can say, or we can do that, so we can say that that is okay. We can do another more. This is negative and this is positive, right? So now again this will be V high, that is as it is, and then we have to take that. Now you can see, so that is very low. Now we can say this is actually the specific volume, root of the equation from the bisection method. So that specific volume of the gas is 0.1738 using bisection method. So now, so what will be the specific volume? Specific volume using RK equation and bisection method is equal to 0.17381 liter per mole. So that is the answer. That's it. So you know what will be the specific volume? Specific volume is 0.17381 liter per mole if I using bisection method. So that way we can solve. Thank you.